So when you hear the term electroplating, you probably think of, shiny chrome bumpers on a classic car, or maybe some fancy silverware. But honestly, that's barely scratching the surface. What we're going to get into today is how this incredible process is used to give ordinary materials some truly extraordinary new powers by engineering them one single atom at a time.
It all boils down to this one huge question. How do you fundamentally change what a material can do without actually changing the material itself? Well, the answer, as we're about to see, is all about creating the perfect, high-tech, high-performance surface.
Okay, so what is electroplating really? At its core, it's actually pretty straightforward. You just use an electric current to coat an object with a super thin layer of another metal. But here's the thing, this is not like a coat of paint. Oh no. You should think of it as a precisely engineered, custom-fit suit of armor designed for a very specific mission. And that mission, a lot of the time, starts in the heavy-duty industrial world, where materials are put under some unbelievable stress. This is where we meet the real workhorses of electroplating, nickel-based alloys.
And this is where you can see just how customizable that armor really is. By adding a different key ingredient to the nickel, you can give it a totally distinct superpower. You add some phosphorus, and bam, you've got a shield that's incredibly resistant to wear and rust. Swap that for boron, and suddenly it's super hard, but still flexible. And cobalt? Oh, that lets us do all sorts of cool stuff, like fine-tuning its magnetic properties, or even making it speed up chemical reactions.
But here's the thing, we're not just stuck with two ingredients. This is where modern material science gets really, really creative. What happens if we decide to add a third element to the recipe, something like copper, into that nickel and phosphorus mix? You can really see the difference when you look at them side by side. On a microscopic level, your standard nickel phosphorus has this rough, kind of lumpy, cauliflower-like texture. The problem is, it can flake off when you put it under pressure. But when you add that copper, the whole structure changes. It transforms into these tiny, perfectly uniform spheres. And because that surface is so smooth and consistent, it spreads out any stress evenly. It just doesn't peel away when the going gets tough. So just how much tougher are we talking? Well, get this. That one small change to the recipe makes the new Nipcrow coating more than 8 times harder than the original. 8 times! That is a huge leap in performance, and it all comes from adding a little bit of copper and completely changing the structure of the surface. But it's not always about brute strength, right? Sometimes it's about getting smarter and a whole lot safer. To see what I mean, let's take a look at the evolution of a real classic, silver. You see, for decades, the process of putting that beautiful conductive silver layer on everything from jewelry to electronics, well, it had a really nasty secret. It required these chemical baths that were filled with highly toxic cyanide, which was a huge risk for workers and, of course, for the environment. So the solution was to go back to the drawing board, chemically speaking. Scientists came up with these new cyanide-free baths, using things like thiosulfate that could deliver the exact same high-quality silver coating, but without all that extreme toxicity. It's a perfect example of how the whole field is evolving to be so much more responsible. And this evolution, well, it leads us to the most incredible, most demanding place you could ever imagine for a material, the inside of the human body. This right here is the ultimate frontier for surface engineering. Now, titanium is an amazing material for medical implants. It's super strong, and our bodies generally don't reject it, which is great. But just the raw metal itself isn't enough, because with implants, the surface isn't just part of the story. The surface is the story. It's the critical zone where the device meets your living tissue, and it has a very, very complex job to do. So what is that job exactly? Well, a perfect implant surface basically has to pull off 4 things all at once. First, it's got to be tough enough not to wear down. Second, it has to actively encourage your own bone to grow right onto it. That's a process called osseointegration. Third, it has to resist being corroded by all the fluids in your body. And finally, it has to fight off dangerous bacteria to prevent infection. I mean, that is a massive checklist. So how on earth do scientists pull all of that off? Well, one of the most powerful tools they have is a technique called plasma electrolytic oxidation, or PEO for short. It's this really cool high-voltage process that basically grows a hard ceramic-like layer directly on the titanium surface. And the structure that PEO creates is, well, it's just brilliant. It's like you get a 2-for-1 special.
The outer layer is porous, kind of like a coral reef, and it gives new bone cells this perfect scaffold to grab onto and grow right into. But underneath that, the inner layer is dense and solid, and it forms an impenetrable barrier that seals the titanium off and protects it from corrosion. It's just fantastic engineering.
And we can make that surface even smarter. Scientists can actually dope these coatings by mixing in specific elements while they're being made. They can add silver, which actively kills bacteria. They can put in magnesium and strontium, which basically send signals that tell bone cells to grow faster and stronger. They can even add silicon just to make the surface harder. Each one gives the implant a new active superpower.
And if you think that's cool, the innovation doesn't stop there. The absolute cutting-edge stuff is straight out of a nature documentary. Scientists are now copying the unbelievably powerful glue that mussels use to stick to rocks in the ocean. They're using that idea to create these special coatings that are not only super sticky, but also help the implant get along with the body while fighting off bacteria. It's amazing.
So what's the big picture here? Whether we're talking about heavy industry or deep inside the human body, it's clear that the most exciting, game-changing innovations in material science are all happening right on the surface.
Look, if you take one thing away from all of this, let it be this. We are so far beyond just polishing metal here. This is fundamental engineering. This is about manipulating materials atom by atom to unlock entirely new capabilities, to make them stronger, safer, and a whole lot smarter.
It really just gets you thinking, doesn't it? Today, we are literally building surfaces that can integrate with our bodies and help heal us. But what about tomorrow? As we get better and better at controlling surfaces at this tiny, incredible scale, could we one day build them to generate their own power or store energy, or maybe even process information? The future, it seems, is really just a surface away.